Hey guys, so this is going to be the first YouTube video from where we're trying this as a form of asynchronous learning. That way you guys get a YouTube video the day before your Teams meeting, or hopefully more than a day depending on the circumstances and what we're doing. You have time to watch the video. I'm going to try to keep the videos to roughly about 10 minutes just to make it really easy for those of you that have internet that causes issues. That way you can have time to open the video, let it sit there and buffer, and then come back to it later whenever it's actually fully buffered, so you can just watch it through. And then we're going to have our Teams meetings like normal. Teams meetings are going to be used as a mix of office hours, place time where you can ask questions. We can examine formative assessments, so examine like quizzes and assessments and things like that, like quizzes you've taken, and answer any questions related to that, and so on. So we're going to jump right into it. I'm going to try to keep, like I said, keep the video to about 10 minutes or less, hopefully. So we're actually jumping into a new topic from where we're finally starting to start talking about Earth and not just space and Earth and space science. So to lead us off, we're going to talk about the geologic timescale of Earth. So I'm going to pull up the PowerPoint, minimize or reduce the size of my camera, and let's get going. Okay, so geologic timescale. So we're talking everything that's happened from the very, very start of Earth. It's like Earth's formation to this exact instant. So geologic timescale. It's essentially a record of Earth's history from origin, and it continues up to our present time, like I just said. So start of Earth to this exact moment that you're watching this video. So whenever we're talking about geologic time, there are a couple different units of time that you need to understand. The first one is going to be eon. So an eon is the largest unit of time on the geologic time scale. It's going to consist of, there are 4 major eons over the history of Earth. We have the Hadean, the Archean, the Proterozoic, and the Phanerozoic. Our 3 earliest eons make up 90% of geologic time. Those 3 eons are also known as the Precambrian, which you guys may have heard of. We are currently in the Phanerozoic eon. So, our Hadean eon. It's our oldest eon. Earth was characterized by a molten surface, volcanism, and large numbers of asteroid impacts, similar to like what happened to the moon. That's why the moon has those asteroid impacts. Earth has just had a way to clean it up, right? So, Earth was extremely hot. It was a newly formed planet, going through radioactive decay and major asteroid impacts, so constant asteroids like colliding into it. So we're talking early universe whenever we saw the formation of Earth. So anyways, we don't really have fossil records from the Hadean eon, so we don't really know if life existed. We do know that liquid water was present at this point in time, though. So from our Hadean eon, we move to the Archean eon, which is Greek for the beginning. In particular, it's referring to us starting to have a fossil record and a rock record. So this is the point where we are able to start identifying the fact that life existed. So this is most likely the period for the beginning of life on Earth. In theory, technically, it could have been the Hadean eon. This is just whenever we know that we had life. And we detected this via chemical signatures found in rock formations. So early life forms on Earth were mostly chemosynthesizers, similar to photosynthesizers. So instead of using sunlight to make food, they used various chemicals that were found on Earth. A lot of extremophiles, like things that live down like the vents of the ocean floors, are chemosynthesizers. And I'll try to see if I can come up with an example if you guys ask me on Tuesday. So, other major things from the Archean eon. So, we saw the formation of Earth's crust, and late in the Archean eon, we saw photosynthesizers. So, we saw organisms that took sunlight and made food from them. So, this would also be an important thing because it would have led to, we know photosynthesis, one of the byproducts is oxygen, so we have started to see oxygen start to populate our atmosphere because Early Earth atmosphere was not very kind towards carbon-based life like us. We would not have been able to exist during that time period. Okay, so that brings us to our third eon, the Proterozoic eon. So the third eon, so notice that we saw those photosynthetic organisms at the end of our previous eon. So we saw an explosion of photosynthesizers, and it led to the great oxygenation. So our atmosphere is starting to get lots of oxygen instead of just that little tiny bit from the early photosynthesizers. Other major things that we saw during this, we saw the formation of tectonic plates, which led to the development of things like supercontinents. Because at points in time, we had supercontinents. Our first major one being Rodinia. Probably the most well known that you guys have heard of is Pangea. And this was an era where we saw a major biological step forward. So we went from prokaryotic photosynthetic bacteria, so unicellular bacteria that use sunlight to make food, to eukaryotic organisms. So organisms with multiple cells, organisms that had organelles, so little mini organs that had specialized functions. So this is a huge, huge jump forward in life. All right, so and moving to our, I moved backwards, sorry. So then we would obviously move into the eon that we're in. So our next major unit of geologic time is called an era. So eras are defined by the life forms found on the rock layers. So looking at our Phanerozoic eras, they're named for the relative ages of the life forms, Paleo meaning old, Meso meaning middle, and Ceno meaning recent. So our Paleozoic era, and notice this is probably an era you've heard of, at least you think you know the term because you probably have heard it. So Paleozoic era had lots of ocean life. We had things like trilobites and other hard-shelled organisms emerge, which probably led to things like shellfish and so on moving forward. And we started to see land plants begin to appear later on in the Paleozoic. Excuse me. So our Paleozoic era was eventually ended due to a mass extinction event. So our Mesozoic era was the era of dinosaurs. You guys know what dinosaurs are. You've probably seen and heard tons and tons about them and studied them early on in school. So our Mesozoic era also ended a mass extinction event. Which, whenever I say mass extinction event, what do you think I mean whenever I say mass extinction event? Pause the video for a second. Think about your answer. State your answer out loud and come back to the video. So, you should have come up with an answer at this point. So a mass extinction event is an event that wipes out a large portion of life. We're talking in the 90 percentiles. So probably 90 to 95% of life forms went extinct during these events. So after the era of dinosaurs, we have the Cenozoic era, which led to the rise of mammals. So us, squirrels, cats, dogs, so on. So this current modern era that we're in. So moving on from that, we have our third largest period of time. We have what's called a period. Periods are named for the geographical region in which the rocks or fossils characterizing the age were first observed. So, and then we also have epochs, which are smaller division that make up periods, and these only last for a couple hundreds of thousands of years. And there's an error that I need to fix. So I will have that fixed before I upload this PowerPoint to Schoology. So, that being said, so we have a couple eras of time. Geologic time is really, really interesting whenever you look at the advancement of various major points in history of Earth, and just showing you how little, or for how short of a period of time, we have been the dominant species on Earth. So with that being said, we'll wrap up the video. You guys are going to have an assignment related to the geologic, the geologic timescale, and there's probably also going to be a guided reading to go along with this. which hopefully I'll have the guided reading up Tuesday before class. I will definitely have the worksheet up related to the geologic timescale, so make sure you work on that tomorrow. All right, guys. I will see you guys Tuesday, and let's get to it.